Hello everybody, myself Prashant Mukhopadhyay, faculty member Electrical Engineering Department, Greater Kolkata College of Engineering and Management. During our last discussions of power electronics and drives regarding this unit of switching and timer circuits, so we will have discussed about the basics, its operation, timing circuit of IC 555 as Astable multivibrator. So, and we have also discussed the Astable multivibrator as a square wave generator. We have seen, and we have discussed two circuits, alternative circuits for square wave generations. Today we'll discuss another applications of pulse position modulations with this 555 timer circuit using in as a in a multivibrator circuit. So in pulse position modulation, the position of the pulse varies according to the modulating signal, while the amplitude and the width of the pulse are kept constant. So the position, this is very important. You see the name pulse position modulation. That means position of the pulse will vary. It can be modulated according to the modulating signal, while the amplitude and the width of the pulse are kept constant. Just position will be changed with according to the modulating signal. So the position of each pulse changes according to the instantaneous sample voltage of the modulating signal. And in order to achieve pulse position modulation, actually we have to use two 555 timer ICs. Used in which one operation operates in Astable mode and other in the monostable mode. So since we are already familiar with the multivibrators, different multivibrator circuits using op-amp, that is Astable and monostable and bistable, so we know that its operations and functions. So only depends in monostable we will use in case of op-amp we will be using 555 timer. So with this basic idea, we can definitely discuss pulse position modulation of this multivibrator circuits using Astable as well. Two 555 timers. One is used as Astable and another one is used as monostable mode. So actually, once again, I am telling you this. Pulse position modulation. Be careful about the name. Pulse position modulation. The position of the pulse varies according to the modulating signal, but its amplitude and the width of the pulse are kept constant. Okay, and position of each pulse changes according to the instantaneous sample voltage of the modulating signal. And for this we'll take two 555 timer ICs. One is used as Astable mode and another one is used in monostable mode. So modulating signal is applied at the pin 5 of the first IC 555, and that is operating as the Astable mode, and the second one it is operated in monostable mode. Okay, so the output of this output of this first 555 IC timer, which is used as Astable, is a pulse with modulated wave. So this is the pulse with modulated wave, and this pulse with modulated wave signal is applied as the trigger input as the trigger input to the second IC table 5, which is operating in a monostable mode. I told you earlier that is the very beginning of this discussion. So the position of the output pulses of the second IC, that is IC table 5 timer, changes according to this PWM signal, pulse width modulation signal, which is again dependent on the modulating signal. So this output depends on this modulating signal, and this is given to the second triple 5 timer, and its position can be changed on this PWM. Okay, which is again can be changed by this modulating signal input. Okay, so this is the schematic diagram of pulse position modulator using two 555 timer ICs. This is shown here. Okay, see this picture carefully. Now the threshold voltage for the first timer, which is determined by the control voltage, that is the modulating signal, is changed to upper threshold level and is given by, this is the 2/3 of the supply voltage plus the V mod, that is modulating voltage. So upper threshold level, so it can be written as 2/3 of the VCC plus V mod. So as the threshold voltage changes with respect to the applied modulating signal, the width of the pulse of course changes, and hence the time delay is varied. So as this pulse width modulated signal is applied to the trigger of the second IC, this one, so the width of the pulse changes, and hence the time delay is varied. As this pulse with the modulated signal is applied to the trigger of the second IC, there will be no change in either amplitude or width of the output pulse, but only the position of the pulse is changed. Okay, so this is important. As threshold voltage change with respect to the applied modulating signal, the width of the pulse changes, and hence the time delay is varied. Now, as this pulse width modulated signal is applied to the trigger of the second IC, there will be no change in either amplitude or width of the output pulse, but only the position of the pulse is changed. So, see this one. So, the waveforms of the pulse position modulated signals will be given like this. This is the input trigger. Okay, this is modulating signal, so applied to the pin 5 at the timer IC 551, which is used as a Astable multivibrator. So this is the pulse width modulated output. Okay, this is the output of the Astable multivibrator circuit. Now this is the output of the final output, that is pulse position modulated output. See, okay, position has been changed. So that is a very important application of multivibrator using 555 timer. This pulse position modulation. That is using two timer circuit, IC timer. That is one is used as a, first one is used as a Astable multivibrator, and second one is used as a monostable multivibrator. This modulating signal is applied in the pin 5 of this timer one. This is an Astable multivibrator, and its pulse width modulated output is applied to the for the second timer, and whose output will be the pulse position modulated without any change with the pulse width or pulse amplitude, etc. And that is discussed and given here. So this is the input trigger. This is the modulating signal. This is pulse width modulated output, and this is the pulse width modulated output. So that is about this pulse precision modulations using IC555 timer as Astable along with the monostable multivibrator circuit. Now we'll discuss about this pulse train. We know that Astable multivibrator will generate a continuous stream of pulses by using a potentiometer in place of the resistor R1. A train of pulses can be generated at different widths. We have already discussed when we were discussing the application of this, operation of this Astable multivibrator circuit. So by changing this R1, the duty cycle can be changed, and the train of pulses can be generated in at different widths. The circuit pulse train generated using Astable mode of operation is shown here. Okay. Same, only R1 is replaced by a potentiometer. Clear? Now, see what we can use frequency modulation using Astable multivibrators. So before going to this frequency modulation circuit using Astable multivibrator, we can have a quick recapitulation of the Astable multivibrator. So it's what we have discussed so far. So we have discussed Astable multivibrator using 25 timer circuits. It's used its operation. So its operation. Once again, I'm going back to our discussion. Basically, it will help us to understand before application. So this was our discussion was like this. So here it is actually how it was operated. See, here we have discussed circuits and operations. We have discussed duty cycle. We have discussed applications of Astable multivibrator as a square wave generation. We have discussed square wave, Astable multivibrator used as a pulse precision modulation, along with monostable multivibrator using IC555 timer. Then we have discussed the pulse trend, and all these discussions based on this circuit and operations. This is the basic circuit and its operations. We have discussed the operations, and we got its duty cycle. This is very important. This is the output waveform. This is the waveform actually, and this is the capacitor voltage, charging, discharging, then output voltage form. This is the duty cycle. Okay, so we have this is different value for R1, R2 and C for getting different frequency. Then we have discussed about the Astable multivibrator as a square wave generation by modifying, and for this we have used two of this circuit. This is one circuit, another one. So this is the waveform. This is another circuit. Then we have pulse precision modulation. Then we have pulse. Now we'll discuss the another application of Astable multivibrator, that is frequency modulation. So Astable multivibrator can be used to generate frequency modulated signals. Modulating signal is given to pin 5. That is the control voltage. The circuit of the frequency modulation using Astable mode of operation of IC 555 is shown here. So this is a diode is connected in parallel with the resistors R2. Okay. In order to generate pulse output with duty cycle of approximately 50%. When we have discussed about the duty cycle of the operation of the Astable multivibrator, so 50 cycle output generation, for that we have used this diode across R2. The modulation signal is applied at pin 5 through a high-pass filter consisting of capacitor and this resistor and capacitor. This is a high-pass filter. So according to the modulating signal applied at this pin 5, the output will be frequency modulated. So if the voltage of the modulating signal is high, the time period of the output signal is high. Okay, and if the voltage of the modulating signal is low, the time period is also low. And the waveforms of the modulation signal and the frequency modulated signals will be accordingly like this. See, this is the modulating signal, and this is the frequency modulated pulse. So depending on the signal, say magnitude, actually, this is the modulated signal. So that is all about the applications of the Astable multivibrator. That means we have used Astable multivibrator as square wave generation. We have used Astable multivibrator for pulse precision modulation. We have used for generate pulse train, and then we can use Astable multivibrator for frequency modulations. So with this, we'll conclude our the Astable multivibrator, its operation, its circuit diagram, its duty cycle, its waveforms, its applications in different area, that is square wave generation, pulse precision modulation, pulse train generations, and frequency modulations. With all this, okay. So if you have any questions or queries, you can ask me. As I told you in the very beginning of this power electronics and drives class, I have given my all details where you can contact me either through mail or either through mobile or WhatsApp, whatever the way you can prefer. So let us start the next topic, that is the use of 555 IC timer circuit in monostable multivibrator, actually. So let us start this monostable multivibrator circuit using 555 timer. During this discussion, we'll discuss about the circuit and operations, its pulse width derivation, and then applications. Application as frequency divider, pulse width modulation, linear ramp generator, switching the relay on, missing pulse detector, etc. So let's start the circuit and the operations. So actually here actually only two extra components are required to make the the 555 timer as a monostable multivibrator on resistor and the capacitors. This is shown here. Okay. So, as we have already studied, that is the monostable multivibrator, as its name specifies, has only one stable state. That's why it is also called one-shot multivibrator. Actually, when a trigger input is applied, pulse is produced at the output and returns back to the stable state after a time interval. So the duration of time for which the pulse is high will depend on the timing circuit that comprises of this R and C network. So the connection details is like this. Pin 1 and 8, pin 1 is grounded, pin 8 is connected with the supply voltage VCC. Output is taken from pin 3, okay, and to avoid accidental reset of the circuit, pin 4 is connected to the supply with connection to pin 8. So pin 5 is which is the control voltage input. This pin 5. Control voltage input should be grounded, and when not in use, of course, should be grounded. And to filter the noise, it is connected to the ground via small capacitors of 0.01 microfarad. So this is on here. Okay. Actually. This is all about the circuit and its connections. Now we'll talk about the operation. Monostable mode is also called, I told you, that one-shot pulse generator because it is has only one stable state. And the sequence of events starts when a negative going trigger pulse is applied to the trigger comparator. And when this comparator senses the short negative going trigger pulse to be just below the reference voltage 1/3 VCC, the device triggers and the output goes high. The discharge transistor is turned off, and the capacitors C, that is externally connected to its collector, will start charging the maximum value through resistor R, and the high output pulse ends when the charge on the capacitor reaches 2/3 of the VCC. And the internal connection of IC 855 in monostable mode using the RC timing circuit is shown here. This is the circuit. Okay. Actually, we have already familiar with this circuit. So, see, detailed operation can be explained like this. Initially, the flip-flop is reset. Okay, this will allow the discharge transistor to go to the saturation. Okay, saturation, and the capacitor C, which is connected to the open collector, then in case of CMOS of the transistor. Okay, C this is connected to the collector. Is provided with a discharge path. So this is the discharge path actually. This is discharge path. So when capacitor discharges completely and the voltage across it is 0, and the output at pin is 3 is low, that is 0. When the negative going trigger pulse input is applied to the trigger comparator 2, so then negative going trigger pulse actually applied to this trigger comparator 2. So comparator, it is compared with the reference voltage of 1/3 VCC, and the output remains low until the trigger input is greater than the reference voltage. The moment trigger voltage goes below 1/3 of VCC, the output of the computer goes high, and this will set. Okay, so so the this will set the flip-flop. Hence, the output at pin 3 will become high. This output will be high. Okay, and at the same time, the discharge transistor is turned off, and the capacitor C will begin to charge, and the voltage across it rises exponentially. It is on here. Issue. This is the nothing but the threshold voltage at pin 6. Actually, this voltage is the threshold voltage at pin 6. Threshold voltage, basically. So this is given to the comparator 1 along with a reference voltage of 2/3 of VCC, and the output at pin C will remain high, and until the voltage across the capacitor reaches 2/3 of the supply voltage VCC. So the instant at which the threshold voltage, which is nothing but the voltage across the capacitor, becomes more than the reference voltage, the output of the comparator 1 goes high, and this will reset the flip-flop, and hence the output at pin 3 will fall low. That is logic is 0. That is the output returns to its stable state. And as the output is low, the discharge transistor is driven to saturation, and the capacitor will completely discharge. Hence, it can be noted that the output at pin 3 is low at start. When the trigger becomes less than 1/3 of supply voltage VCC, the output at pin 3 goes high, and when the threshold voltage is greater than 2/3 of VCC, the output becomes low until the occurrence of the next trigger pulse. A rectangular pulse is produced at the output, and the time for which the output stays high, or the width of the rectangular pulse, is controlled by the timing circuit, that is the R and C, and the charging time of the capacitor, which depends on the timing constant RC. Okay, so actually this is the operation, and this is the circuit as I so as you are seeing here. This is the circuit diagram. This is two comparators, comparator 1 and comparator 2. This is threshold voltage. Output is given to the R reset, and this is comparator 2, which output is given to the set. Okay, this is the charging part of the capacitors, which voltage is actually say used as a threshold voltage. Okay, this is if it is more than that, then it will be coming to one state, and this is the discharge part of the capacitors. So actually, so it is this multivibrator. It is monostable or one-shot generator, because it can stay in one stable state at a time, and unless and until the next trigger pulse is provided, it will not come back to. It will stays this state, and if one's next pulse, when it is applied, it will say come down from this state, and it's the next step. If it is high, this will come to low, and then again will stay in the low, unless and until the next pulse is coming. So then if next pulse comes, it will go to the high, and for the next triggering pulse, it will again come to the low. So in this way, this say multivibrator using this 555 timer will act as a monostable multivibrator, and that's all about this discussion.